Thank you, Nick. I would like to thank Mr. Nick Ramfos and Adam Hobbs from NOCoE for giving us this opportunity to present Nevada DOT's TSMO program. This was initiated a little more than a decade ago, and I'll be presenting how far we progressed to date. Next slide, please. So here you see a snapshot of our progress with the TSMO program. It started in 2014, and NDOT conducted its first capability maturity model workshop that set the stage for statewide TSMO guidance. In 2017, NDOT initiated the development of the statewide TSMO program, and we used the 2014 CMM action items as the foundation. The program plan also included a business case that highlighted the operational challenges and the value of TSMO. So following the adoption of the program plan in 2020, we conducted another round of CMM assessment to measure the progress and performance over the past years and use this to formally develop and implement the progress in our planning documents. And using the 2020 CMM results, NDOT tailored, modified its TSMO implementation with planning phase tasks and initiated the development of 4 plan documents, including staffing and workforce development plan, performance management program plan, the planning and financial resources, processes and procedures, and the stakeholder engagement plan. The business case for TSMO was also updated in 2023 to reflect all the latest trends and the challenges faced by Nevada's transportation system, and it highlighted TSMO activities across all NDOT divisions beyond traffic operations. In 2024, we conducted the last CMM workshop to reflect current capabilities and identify goals and action items for the future. 2024 was also a significant year as we implemented and started the management of the statewide TSMO program. Next slide, please. So looking at TSMO in action, the figure on the left shows how traditionally projects go through a project life cycle, scoping, design, construction, and maintenance. When we started our TSMO program development process, we realized that there were opportunities for integrating TSMO strategies. So we started at the planning phase. And for the implementation of TSMO strategies through the life cycle, we incorporated specific TSMO tools and processes that I will talk in the slides coming on for a more collaborative and integrated approach for project development and safety and delivery. To make sure operations is not an afterthought, we integrated these strategies from the early stages of project development. So for the planning stage, we developed the TSMO investment prioritization tool, the IPT. For scoping and programming and design concept development, we developed the TSMO evaluation tool. For construction, we integrated our traffic incident management program, the TIM coalition, incorporating work zone management strategies and through stakeholder engagement through this coalition. We invite district engineers in the region where we are conducting these TIM coalition meetings to discuss upcoming and current construction and maintenance events in the area. We also invite construction project managers to talk about large projects and if they will have a major impact on traffic. A few of these projects in Southern Nevada, Project Neon, I-15 Tropicana Interchange, and the high-speed rail Brightline, just to name a few. In Northern Nevada, in the city of Reno, Sparks area, we have the Spaghetti Bowl Interchange and North Valley construction that is still ongoing. We have also been asked to provide 4-hour TIM training to many of our personnel that work on these projects to help minimize the disruptions in case of an incident in a construction zone. During Project Neon, we trained about 100 construction personnel. We also assisted contractors in planning a mock construction incident. An example was like a crane collapsed, and how would they go about managing the incident in the zone? Over the years, we have found that our stakeholders are very appreciative and like having updates so that their agencies are notified of the changes and closures. We also provide our stakeholders with highway road restriction reports so they can manage traffic accordingly. So, for the operations and maintenance, we established the asset management tools and strategies to assist with meeting device specific operational and maintenance goals. An example of this is the life cycle cost analysis tool that I will be talking about uh, in the slides coming up. The TSMO's tools. I will talk about each stage. The first one is the integration in planning process, and this is the TSMO IPT. So the investment prioritization tool was developed as a TSMO strategy to ensure operational objectives are accounted for during the project selection and prioritization process. And during the implementation process, this tool was integrated into the business process, such as our ITS and ATM master plan. So, developing this prioritization framework, we placed a great focus on including both qualitative and quantitative analysis and the scoring criteria that you see to the extreme right, the column. So, together with our stakeholders, we identified the following criteria for the ITP, which is how does each of these projects enhance safety, with it helps in the preservation of infrastructure, optimize mobility, um, and we have a discussion with them on each of these projects in the planning phase. Our leadership also recognizes the value of TSMO as a core value within the DOT, and hence they have identified Traffic Operations Division to be one of the key stakeholders in the planning stage to make sure that operational objectives are prioritized very early on. So based on the above criteria, this tool assigns an overall TSMO score for each of these projects, and that's how we prioritize these projects based on the TSMO score from the highest to the lowest. Next slide, please. The TSMO evaluation tool is developed to assist in the assessment and evaluation of the projects as they go through scoping, programming, and design. The tool will ensure a targeted evaluation of the project scopes against key objectives of TSMO. The process begins with the project design team conducting the evaluation. And the first step in this process is the evaluator, the project manager, to complete level 1 analysis questionnaire. And depending on the responses to the questions in this level, the tool may actually trigger a level 2 analysis, which will then go on into further specific details to a TSMO objective. This process continues until all triggered analyses are completed. And at the end, the tool will automatically populate all the recommendations into a form. This form will then be added to as part of the documentation and put into the proposed scope revisions if required. So if the evaluator answers no to all the questions in level 1, then they would have to fill out a TSMO waiver form, meaning that all opportunities for TSMO integration have been considered and relevant strategies have been adopted. So TSMO integration in project construction, this is mainly done through our TIM coalition, which actively collaborates with all our stakeholders to minimize the impacts of construction on the traveling public and also operational activities. Here we are presenting 3 examples of ways we accomplish this. First is developing the traffic management plan as part of the design package. This comprehensive strategy outlines how to manage optimized traffic flow, particularly during planned events or disruptions, and by employing various techniques and technologies. The second strategy is the traffic incident management program. We are very proud to have a very mature TIM program that enables a very structured coordination and collaboration through its coalitions. We use these coalitions as an opportunity to discuss major construction projects, roadway closures, and coordinate for potential traffic challenges with law enforcement in preparation for major construction activities and for the duration of the construction project. Our coalitions are held every 2 months in the cities of Reno, Carson City, the capital, and Las Vegas, and every quarter in our rural areas. Last but not the least, we allocate resources to help organize our stakeholders and public outreach through publications, materials, share information regarding construction and roadway closures in advance. Our traffic management center in Las Vegas, the team members there are part of the key stakeholders in this group and helps them prepare post travel information messages through DMS signs in preparation for major planned closures or construction events. In northern Nevada, keeping Interstate 80 open, especially during the winter months, our road up centers in eastern Nevada and Elko and western Nevada and Reno help, trucking company, especially the trucking company, to keep goods and services flow through the I-80 corridor. And our TMC staff, along with Southern Nevada RTC, keep Las Vegas moving as it's a year-round destination for events. Next slide, please. So coming to the integration and operations and maintenance, we use the life cycle cost tool. And unlike roads and bridges, ITS assets do not have a formally established performance metric for maintenance conditions. We all know that maintenance activities can impact the operational performance and our life cycle of our assets. Hence, for the purposes of the TAMP, which is our Traffic Transportation Asset Management Plan, we developed a tool to help record the operational conditions of the assets and calculate the required maintenance investment based on the asset's health condition. This really helps us with budgeting. We are really short on budget, and it's going bad to worse every year. And this tool really helps us understand what is required and how we can budget for and work through our budgets. Um, the TSMO Performance Management Program expands on specific definitions by further defining asset priorities. And the first set of definitions we used for the input into the LCC tool are the operational conditions. We established 4 categories: good, low risk, medium risk, and high risk assets. So the second set of them are definitions are based on the assets life cycle. All these definitions and assumptions are developed based on the asset's life cycle, from when an asset is added to when it's to be replaced. We look at all different operational conditions within the cycle. Next slide, please. So finally, using the 4 categories of good, low risk, medium risk, and high risk definitions that were developed for performance metrics of the assets, we developed maintenance definitions for each category. Inspection involves routine maintenance of the device or the asset by NDOT, typically performed annually or biannually based on the type of device. Minor repairs are performed on site, and these include activities such as adjusting loose cables, battery replacement, firmware upgrades. Major repairs typically requires the device to be sent back to the maintenance shop or the factory for repairs, and involves the replacement of 1 or more key parts to ensure satisfactory device functioning. And the replacement of the devices involves the complete removal and replacement of the device. So these categories, together with the operational condition categories, are used by the LCC tool to establish a transition probability matrix to keep us informed regarding the asset's condition during its life cycle. Next slide, please. And here you look at the 10-year investment for Southern Nevada. Some of our devices out here. There are two analysis models that will ultimately be provided using the LCC tool, and this one is the 10-year investment model. Here we work with our external partners, Regional Transportation Commission of Southern Nevada, RTC, and the FAST, which is the Freeway Arterial Service of Transportation. We integrate the LCC into their business processes through our interlocal agreement. And this table considers the current state of the network devices and provides estimates on the 10-year operation and maintenance costs based on the identified maintenance strategy. Next slide, please. The second one is the life cycle cost analysis model. Here it illustrates the life cycle costs of maintaining a brand new network. This example is from the LCC analysis on just all the DMS signs in Southern Nevada. And based on this analysis, the cost of operation and maintenance in the preservation scenario, you can say, is less than half the cost of the first scenario where nothing is done to maintain or assess these devices. Next slide, please. The outcomes, learnings, and benefits of TSMO integration. Enhanced collaboration. The process of formalizing TSMO tools and integrating it into a business process improved TSMO collaboration externally between our local partners. Workforce development. NOC has held multiple trainings and workshops to educate the external partners in operation and maintenance teams on these TSMO tools. Through monitoring of TSMO integration and project development and delivery lifecycle, our internal and external partners have a better understanding of staffing, workforce, and training needs for TSMO implementation. The business process improvements, NDOT successfully integrated and executed TSMO components in the several agreements, such as interlocal agreement between us and the Regional Transportation Commission of Southern Nevada. And the findings and the lessons learned from these TSMO tools are frequently discussed with our stakeholders to efficiently allocate available funding and resources through data-driven and performance-based processes. Operations and maintenance and improvements. NDOT can ensure that these assets are in good condition, identifying resources and requirements to maintain the assets in good condition to further improve safety, mobility, and reliability of our transportation system. Advanced TSMO culture. Understanding the value of TSMO, partners have now enhanced their collaboration to develop, deliver, operate, and maintain TSMO projects and assets, and stay informed regarding operational objectives. We've had multiple training sessions, workshops, and NDOT has advanced in data-driven and performance-based culture. Asset management and performance measure improvements. This tool's operational and maintenance data helps our partners tend to the maintenance and management needs in a timely manner, therefore improving the operational life cycle and deterioration cycle of the assets. All these benefits are mentioned in the Transportation Operations Manual. Next slide, please. So staffing and workforce development. Next slide, please. So staffing and workforce development was formally adopted in 2023 and implemented in 2024 at Nevada DOT. The four key components of this are recruiting a TSMO workforce, and training the TSMO workforce, retaining and integrating TSMO in our educational institutions. Next slide, please. So NDOT staff, with the support of its leadership, worked with the Department of Human Resources Management at the state of Nevada and produced a work plan to develop and approve 5 TSMO positions that align with the 6 CMM dimensions. The TSMO program manager, as part of the TSMO recruiting process, I was hired as the TSMO program manager. My job duties are to advance TSMO culture throughout NDOT, taking the leadership and directing the program across all our divisions to improve on our CMM. The TSMO Performance Manager, as with most DOTs, our projects are capacity projects. The Performance Manager identifies opportunity for the implementation of cost-effective solutions to improve safety, mobility, and reliability of the transportation system. NDOT reports on performance measures to the Federal Highway, and the Performance Manager works with our data analyst, internal and external stakeholders to develop these reports. In the Transmission Operations Manual references all the federal reporting requirements. TSMO data analyst. In a performance-driven culture, the data analyst develops performance measures using real-time operation and long-term trends to support the performance manager and intends to develop predictive analytics. We have a TSMO engineer. Um, advances TSMO integration through the implementation of systems engineering and application of the latest systems and technology either through standalone ITS projects or through roadway projects. And we have a TSMO modeling specialist who helps with advanced planning of operations and assists in performing benefit cost analysis to implement various TSMO strategies, and hence we can allocate resources efficiently. Next slide, please. So this is our organization chart at traffic operations at NDOT. And in order to develop a robust workforce and maximize the efficiency of the TSMO program, we restructure the current organization chart by introducing the 5 TSMO positions that you can see through the different sections of our division, rather than having all the positions in just one section in a silo. This org chart shows you the distribution between the different divisions. The program manager, the performance manager, and the data analyst under ITS planning and operations. We have the TSMO modeling specialist under operations and network analysis, and the TSMO engineer under signals, lighting, and ITS design. And this is the end of my presentation.